James Watson, geneticist, biophysicist, Nobel Prize winner. Together with Francis Crick, he proposed a structure for the main molecule of life, DNA. Their discovery allowed people to understand how the hereditary information is stored in all living creatures, which enabled genetics as we know it today, from DNA analysis to genetic engineering. James Watson enrolled into university at the age of 15, and before he turned 25, he and his colleagues had made the discovery of the century. After that, he started researching cancer. He has been working on this problem for half a century now. In 2018, James Watson will turn 90. He continues his work and gives lectures around the world.
So, Dr. Watson, thank you for coming to Russia and thank you for this interview. Now that is what you're interested in, right? Scientifically, the cancer treatment.
Yes, I've been interested in cancer for 65 years, so long time.
Long time.
Because one of my father's younger brothers died of cancer at an early age, so I was always aware of it. And then with time we discovered that the cancers mutate, and it's sort of the big search was for the genes which made the cancers dangerous, so oncogenes. Mm-hmm. And then they discovered another class called tumor suppressors, which are genes that protect you against cancer. And then if you lose them, then you get cancers. And one of the more interesting things is that very big organisms, which have many cells, they would all die of cancer except they have lots of tumor suppressors. So elephants and whales are filled with genes that protect you. And now one has found that bats, where their wings have to move very fast, they're filled with oxidants, because they need lots of oxygen. Yeah. And so they have less cancer, because their body is filled with oxidants, and oxidants kill cancers.
Phoebus Levine, a famous chemist of the beginning of the 20th century, called DNA a stupid molecule. Nucleic acids were known to biochemists 100 years before the discovery of DNA structure, but nobody considered them as the carriers of hereditary information. Simple, monotonous, repetitive base chains seem too boring for this role compared to large, complex and elaborate proteins.
Then you discovered the double helix.
Yes.
And then you just switched your field?
No, then the basic thing for everyone was find out how the DNA worked in a cell, and how it provided the information to make proteins. So that's what I did in the when I went to my first academic job at Harvard. The question was, what was the genetic code? And that all became a pretty solved problem by the end of the 1960s. It took about 15 years to work out the basic way DNA worked. And then even before we had the details, I wrote by
When talking about DNA, it is impossible not to mention Rosalind Franklin, who, unlike her colleague Maurice Wilkins, did not share the Nobel Prize with Watson and Crick. For a long time, she tried to find DNA structure using her experimental data and X-ray pictures of the molecule. She made a key contribution by making the famous Photo 51. That gave Watson and Crick a hint and led to the birth of the double helix. Rosalind died 4 years prior to the Nobel Prize award ceremony from an ovarian carcinoma. By a bit in irony, it is a type of cancer caused by errors in the DNA.
We wanted to study sort of human cells like we studied bacteria. And they are the cells which were easiest to grow were cancer cells. So we automatically began to study cancer cells, and because it had a big potential practical application to see if we could use this knowledge to eventually cure cancer. And when I went into it, I thought maybe it will take 30 years of pure science, but it's taken more than 50. And it's now 65 years since we found the double helix.
Legendary Linus Pauling almost became the first to discover the secret of DNA structure. In the later years, he did receive 2 Nobel Prizes, but even before that time, it took him months to solve problems which took others years to find the solution to. Pauling had his own DNA model that consisted not of 2 but 3 spirals. He received a Nobel Peace Prize the same year as Watson and Crick.
I was 24 years old when we got the answer, and now I'm 89. And my hope is if I can live another 5 years, I will finally see having a way to cure most cancer. But it's been a long time.
But it's like probably the hardest problem of medicine now, the cancer.
You know, it'll probably turn out to be one of the easier problems. I mean, we still haven't got anywhere with diabetes. I mean, we found insulin, but people still with insulin, they die of diabetes. So diabetes is a very major problem. So most of the, where medicine has had its greatest impact is in the killing of bacteria and viruses, infectious diseases. And so we've cured many infectious diseases. And we now have considerable success in controlling heart disease. But the most important thing was stopping smoking. So
well, that's pretty easy. Yeah.
So our biggest health advance is just stopping smoking.
And speaking about diabetes, for example, can we get rid of diabetes by, for example, genetic engineering?
I would hope not. Well, that would be too complicated and expensive. So you just like a pill.
The first attempt to describe DNA structure turned out to be a failure for Watson and Crick. They had made the same mistake that Pauling repeated later. Their model had 3 spirals and the bases A, T, G, C were on the outer side. They rushed to show the model to their colleagues and were literally destroyed by their criticism. Their molecule would have exploded in nanosecond, so they added more elements to stabilize it, ending up with a real Frankenstein's monster, unstable, fragile and ugly. Later, Crick called their first model a complete fiasco.
Much of medicine is getting expensive, whereas penicillin was cheap. And I don't think Fleming ever became rich. He became famous, but it wasn't. It was the days when medicine was affordable. Now medicine is getting too expensive.
And what maybe other problems do you see in modern science?
Oh, I think if we cure cancer, our major objective will be mental disease, and which there are many types. But mental disease seems to be increasing in amounts. Cancer was increasing because of smoking. Once you stop smoking, then cancer was sort of determined by the rate of human mutations. Rationally, cure cancer, you had to be able to understand cells. And for mental disease, we may have to understand the brain. And the brain is much more complicated. It's many different types of cells. So I think we'll be, trying to understand the brain better 100 years from now. So I think the science of understanding the brain will have a long future.
Why does it take, how do you think, why does it take so long to make research, not only the brain, just in
general? Because I think it's just complicated. And now we've sort of discovered we have about 20,000 genes, but they can exist in 100 forms. So I think it's sort of as if we have 100,000. That's just more than the brain can easily remember. So the brain, we're sort of forced onto computers to store the information and maybe to understand sometimes the information.
DNA molecules are complementary. A is always opposite to T, G is opposite to C. When it was realized by Watson and Crick, they understood that the secret of DNA self-replication is also there, in its structure. The process itself was described later, but the scientists did make a remark. It has not escaped our notice that the specific pairing we have postulated immediately suggests a possible copying mechanism for the genetic material. Crick later clarified that it was a compromise, as Watson wasn't so sure about their conclusion, and Francis was eager to point out that they were the first to notice this fact.
Science has suddenly become more difficult now when we move toward the brain. Bacteria was not for everyone, but it was. It never seemed too complicated to. And so, in a sense, we know how to cure infectious disease because our enemy is or viruses. But when your enemy is misfunctioning of the human brain, partly brought on by the stress of society, it's more difficult to live today than some things are easier and some are harder, but I think generally to function now, you have to use the brain more than we did maybe 100 years ago.
Well, isn't that a good thing? You use your brain more.
Yeah, but the brain hasn't evolved to handle the stress put on the brain. So we're finding more mental disease possibly due to more stress.
Because more people use brain harder, and so it triggers something.
You have to use the brain. In a sense, maybe you have to be smarter to live now than you did 100 years ago. Where 100 years ago, your chief enemy were poverty, and which can be solved if you know how to produce food. And so food is not as limiting as it was in the past. Now the limiting things may just be jobs, because the jobs can be done more efficiently by machines. And so that's creating a great crisis, and we're suffering from the fact that you may have to be smarter to survive, and all people don't have equal intelligence, and that means some people have an advantage over others, and maybe more so now than 100 years ago, but I can't be sure.
For Watson and Crick, a huge source of inspiration and ideas was a book by a great physicist, Erwin Schrödinger, who is famous also for his thought experiment with a cat. The book was called What is Life? 10 years before the DNA processes were understood by scientists, Schrödinger proposed that the heredity is contained in some molecule made up from non-repetitive sequence of atoms, basically genes.
Everywhere in the world, there are more rich people and with more unemployed people. So it's we don't know how to solve that problem yet, and I'm not sure I know how to solve it.
Well, some people see the solution in education, to educate as many people as possible.
But I think, I'm afraid education won't solve it as the world gets, because the brain evolved to work in a simpler world. And so evolution has to sort of catch up. And how do we make things more equal? One answer, which has been the state, our countries, trying to educate our people better, and that seemingly worked, and things were getting better during most of the 20th century. But now suddenly, at least in the United States, or I think you'll find it true in Russia, that some people so how do you redistribute the wealth? So certainly it's a crisis in the United States where how do you make life fairer? And so I have sort of two heroes now, the Pope, who seems to be wanting to look after everyone, and as a politician in the United States, Bernie Sanders, who sort of says we have to look after everyone. Whereas both our political parties seem to be wanting to look after only the rich. And so that's a crisis. The rich will get richer and richer, and the poor get more and more. It used to be everyone might own a car. Individual country. Is life getting better for more people in Russia? And I think the answer is yes, but you started at a lower level. And we're at a higher level in the United States, and we're finding it hard to maintain. So we have a big social problem, which I don't think will be solved by science. I think it'll be, if it is solved, it'll be solved by human beings trying to help each other instead of just compete.
Watson and Crick were very close friends, preferring talking to each other to almost any other spare time activity. Once, while walking with a friend, Watson, after being silent for a long time, said, The trouble is, you see, that there is only one person in the world that I can talk to. At first, Watson and Crick worked in the same lab together with John Kendrew and Max Perutz, who also received their Nobel Prize in 1962 for studying hemoglobin. But when their group got a new room, John and Max gave it to Watson and Crick, so they can talk to each other without disturbing people around.
I think that was the great success of Christianity, in the sense that it tried to say you had to help the people at the bottom. So that's why, it may seem paradoxical that my great hero was not a scientist, but the Pope. Wow. But when I was a boy, my great hero was Franklin Roosevelt. Well, we had a depression. 30% of Americans were without jobs. So someone had to save everyone. And cynical people say Roosevelt would have never done it, but it was the Second World War that put everyone to work. But then after the war, for about 50 years, it seemed to work. And now it's slightly falling apart. And so now I would like my photo next to the Pope. Whereas in the past you would say, I want my photograph next to Einstein or Dick Feynman or someone, but, if Feynman were alive, he wouldn't solve this problem. To a certain extent, evolution solves it by making people like other people and enjoy working with other people. So by ourselves, we're all pretty impotent. Even the very rich are impotent unless, stable, where we're not fighting each other. So.
Actually, yeah, that's an interesting point about helping others and working together. The story of how you discovered the double helix is a story of competition and collaboration. Yeah. And which is more useful to drive as a driving force of research of science? Competition or collaboration?
Collaboration.
And then, just a little question: what prevented you from working all together at that time? I mean, with Pauling, with Wilkins, with Franklin. Well, because probably the problem would be solved faster.
The main thing then, society had, or at least our country had, supporting young people to go into science, and I never worried about money. I didn't have much, but I could be a scientist, and at one time science was restricted to the wealthy people, but suddenly it was restricted to anyone who was capable of doing it. It was a much larger number of people.
Watson on sax. To Francis' dismay, I showed little tendency to concentrate on DNA when my summer holiday ended. I was preoccupied with sax, but not of a type that needed encouragement. The mating habits of bacteria were admittedly a unique conversation piece. Absolutely no one in his and Odile's social circle would guess bacteria had sex lives.
My success came from my being curious and wanting to know why, and I tried to emphasize it in my book Avoid Boring People, which has just now been translated into Russian, and which the question is always to ask finally why something happens. You know, how can children be like their parents? There was an answer, and the answer was information in the chromosomes, and then that meant information in a DNA molecule. And then once we knew it was DNA, then how did the DNA work? And that was then a problem in chemistry. So I started out from being just not needing to know any chemistry, but that if I wanted to know the answers, I had to think like a chemist.
And you also had some help from your colleagues.
Oh, yes. And Francis Crick was a very good brain. And we got on fine because we had a common objective, which was understanding DNA.
Later, Crick would write, "Jim and I hit it off immediately, partly because our interests were astonishingly similar, and partly, I suspect, because a certain youthful arrogance, ruthlessness, and an impatience with sloppy thinking came naturally to both of us."
Yes, so, but I mean, you got along with Francis and you were...
I think on the whole, I got along with most of scientists. You know, I didn't, at Harvard, I had good students who were happy to work with me, and when I was running the Cold Spring Harbor Laboratory, I always put the interests of the other people ahead of myself. And that's the best way to lead.
Right.
So I somehow wanted to be a leader when I was young. You know, I wanted, in a sense, to run things, and maybe because I had become educated and I knew enough to lead. Mm. And so I didn't want to be led by someone who was dumb.
True.
And everyone sort of needs leaders.
Smart leaders.
Yes, smart and also unselfish leaders, people who really care about the people, not just themselves. So I was lucky. I was sort of a family which really was not totally selfish, which really wanted the world to be better, not just themselves. But I think that, you know, comes out of human nature. That is, the successful people liked other people, and therefore could work with them. And when you work with people, you can do much more than you do yourself. So, and I see it all as a process of evolution by selection for that which works best. And as opposed to, you know, believing there was a God who ran the world, I see that the world sort of runs itself in a Darwinian way. So the big idea I grew up with evolution, Darwinian evolution. So that's what I was trained to do. And then suddenly, you know, we understood the chemistry of life, and we could, you know, be even more ambitious. It's so important to somehow work together to help those who have fallen or don't know how to get up. It's necessarily very complicated, you know. When I was young, I was ambitious that I did something, and then once I'd done something myself, I wanted other people to do some things. So you have to expect young people to become want to be successes themselves and not depend on other people. But then, if you become successful, then you have to worry about other people's success. So do it by following a religion, or whether it's just human nature that makes you do it. I believe it's human nature, which is the evolution has produced some, sometimes you could say, people who care for each other. But there are other animals that don't seem to care for each other the way humans do.
Speaking of success, you probably achieved the biggest success in science, Nobel Prize.
Yes.
What did it mean to you personally?
Oh, the most immediate thing was I got enough money to buy a house. So it was practical. If I just got a medal, the medal was gold, or it was worth something. And so the Nobel Prize did have it changed me, and.
In 2014, Watson decided to sell his Nobel Prize medal for the discovery of DNA structure on an auction to finance scientific research. It was purchased for $4,100,000. The same year, the buyer, Russian billionaire Alisher Usmanov, returned James Watson his medal. Watson was the first person in history to auction his Nobel Prize medal.
So I've always been aware that, that money is important, and it lets you do things, and you have to have a society where everyone has enough money to have dreams. So, just hope things will get better.
And as a Nobel Prize, as a sign of that other people recognize your achievements
yes.
scientifically, that was it important for you that you got this recognition?
Oh, it helped. I mean, in the sense of, but before I had the Nobel Prize, I got a good job at a great university, so my success was recognized. Mm-hmm. So if I hadn't got a Nobel Prize, I would have still had a successful life. But it did let me buy a house.
Which is good.
But maybe I was, since I'm born rather poor. I've never thought material possessions were that important. You could say I thought spiritual, but on the other hand, it's nice to have a nice house, or it's nice to, I collect paintings. I'm happy I have, my house is beautiful. It's helped, to share my life with a wife who has sort of similar objectives and values. I've had a very good life, setbacks, but I am still optimistic.
What makes you happy?
I think, a good meal. So I'm just trying to say that I know what I want to eat for lunch. And, I know, I'll go to bed, my wife will be next to me. If she was next to me, I wouldn't be happy, yes. So that, but I think as people go, I was born sort of, it's slightly easy to make me happy. Some people seem to be never happy. Whereas, people could say I was a happy child, but, and I was happy without money, or I was happy without having lots of people saying I was good or something. I could be sort of happy by myself. If I have a good book, I'll be happy. So a lot of things make me happy, but in the last analysis, it always goes back to people.
And is there anything you maybe would like to change in your life if you had a chance?
Not much. No, I mean,
You're satisfied with your...
Well, if I'm not satisfied, I'm slightly crazy. In that, I've had more sort of big personal achievements than most people, and I still want to. I still am able to look forward as opposed to look backward. I'm not looking and saying, "Oh, I was a good tennis player." I can say, I still am a tennis player. So that's. Some people think, you can just look back and be happy. I have to look forward.
By the way, speaking about future, I know that you were good friends with Sergei Kapitsa.
Yes. Well, he was a very admirable person, but of course he came out of an admirable family.
Yeah, and so he had this program on TV, a talk show, where he asked scientists to make predictions for the future. So, do you have any predictions about any, a view of the world in 50 years or 100 years?
No, I would just, I have hopes. I hope there will still be great people or there'll be great nations. My hope would be the United States will recover itself. Or my hope is that Russia will remain a great nation. The Russian people have accomplished so much. I just wanted them to go on and accomplish more. I'd really like to write a book about curing cancer, but I can't yet. I could write a book about trying to cure cancer, but I would like to win before you write the book.
That's good. Well, let's hope that what will happen. We have our audience who are watching us. It's about 500,000. Lots of them are young people, 18 years, 20 years, searching their way in life. So maybe you have something to say
I guess don't avoid the truth. Just move forward with your truth on your side. That's my advice. But, the truth about me has been pretty good, so I don't have to avoid it. But I'm just saying that, I tried to establish new truths. So you try and think, yes, in a sense, if you worship anything, you worship the truth. That's my...
Okay, thank you very much, James, for this interview, and I really hope to see you again here in Russia. Maybe you're giving a talk on how you...
whether as long as I'm able to walk, I'll come back to Russia.
That's great. Thank you very much.
Brought me in here, and I think to myself, what a wonderful world. What a wonderful world.
Which have many cells. They would all die of cancer except they have lots of tumor suppressors. So elephants and whales are filled with genes that protect you. And now one has found that bats, where wings have to move very fast, they're filled with oxidants, because they need lots of oxygen.
Yeah.
And so they have less cancer because their body is filled with oxidants, and oxidants kill cancers.
Phoebus Levine, a famous chemist of the beginning of...
Then with time discovered that the cancers mutate, and it's sort of the big search was for the genes which made the cancers dangerous, so oncogenes. Mm-hmm. And then they discovered another class called tumor suppressors, which are genes that protect you against cancer. And then if you lose them, then you get cancers. And one of the more interesting things is that very big organisms.
The 20th century called DNA a stupid molecule. Nucleic acids were known to biochemists 100 years before the discovery of DNA structure. But nobody considered them as the carriers of hereditary information. Simple, monotonous, repetitive base chains seem too boring for this role compared to large, complex and elaborate proteins.
Then you discovered the double helix.
Yes.
And then you just switched your field?
No, then the basic thing for everyone was find out how the DNA worked in a cell and how it provided the information to make proteins. So that's what I did.
Problem for half a century now. In 2018, James Watson will turn 90. He continues his work and gives lectures around the world.
So, Dr. Watson, thank you for coming to Russia and thank you for this interview. Now that is what you're interested in, right? Scientifically, the cancer treatment.
Yes, I've been interested in cancer for 65 years, so long time.
Long time.
Because one of my father's younger brothers died of cancer at an early age, so I was always aware of it. And
James Watson, geneticist, biophysicist, Nobel Prize winner. Together with Francis Crick, he proposed a structure for the main molecule of life, DNA. Their discovery allowed people to understand how the hereditary information is stored in all living creatures, which enable genetics as we know it today, from DNA analysis to genetic engineering. James Watson enrolled into university at the age of 15, and before he turned 25, he and his colleagues had made the discovery of the century. After that, he started researching cancer. He has been working on this project